Hello everyone, this is Meghana. In this video, let's learn about desirable properties of transactions and characterizing the schedules based on recoverability from the subject of database management system, which bears a course code of 21 CS 53. So let's get started. Let's have an introduction to the database transactions, where it refers to a sequence of one or more operations that are executed as a single unit of work. Operations within a transaction can include reading from or writing to a database. Transactions ensures the consistency and integrity of a database by following specific properties in it. What are the importance of desirable properties in database system? Where it's going to prevent the data corruption, maintain a consistent state, and provide mechanisms for recovery from failures. The significance of these properties is a paramount in applications where data accuracy and reliability are crucial, such as banking systems, healthcare databases, and etc. Desirable properties often encapsulated in the asset properties, where A stands for atomicity, C for consistency, and I for isolation, D durability, where it's going to play a crucial role in a reliability and integrity of database transactions. These properties ensures that database transactions are executed in a reliable and predictable manner. So let's learn in depth about asset properties. At first, where A stands for atomicity, where it ensures a transaction is treated as a single, indivisible unit of work. Either all operations within the transactions are executed successfully, or none are. There are no partial commits. Like for example, in a fraud transfer, both the debit and credit operation should occur together. If one fails, the entire transactions will fail. So the next one is consistency, where it ensures a transaction brings the database from one valid state to another. The database must remain consistent before and after the transaction. Any data modification should be abide by predefined integrity constraints. Like for example, if an operation violates an unique key constraint, the transaction is rolled back to maintain consistency. The next one is an isolation, where it ensures the execution of transactions is independent of each other, and transactions should be like operated in an isolated way, as if they were the only transactions in the system. The concurrent execution of transactions should not interfere with each other. Like for example, one transaction reading a record should not be affected by the another transaction, like while updating the same records. The next word is D, where it stands for durability. It defines as an effect of committed transaction persist even after a system failure. Once a transaction is committed, its changes are permanent and survive system crashes or restarts. For example, if a user receives a confirmation message from a successful transaction, the data changes should persist even if the system crashes out. In next one, like we are going to categorizing the schedules based on their recoverability. Desirable properties ensure the correctness, reliability, and integrity of transaction schedules in database system. In addition to asset properties, several other characteristics contribute to the optimal functioning of transactions, where it includes recoverability, where it defines the ability to restore the database to a consistent state after a failure, where it also going to give guarantees that committed transactions effects persist despite system crashes or errors. Like for an example, a power outage interrupts a transaction and recoverability ensures a successful database restoration. The next one is cascadelessness, a property preventing cascading rollback initiated by the failure of a single transaction, where it's going to avoid the unnecessary rollbacks, minimizing disputes caused by a single transaction's failure. For example, transaction if a transaction T1 fails, but cascadelessness prevents transactions depend on T1 from being a rollback. The next one is a strict schedules, where it ensures the transactions read or write only committed data, enhancing schedule correctness. It also going to prevent reading uncommitted data, contributing to the consistency of the database. For example, a strict schedule ensures that a transaction reads only the data committed by other transactions. In conclusion, we can conclude where a critical foundation in a desirable properties are categorized schedules from the critical foundation of robust and reliable database system. They serve as a guiding principles for ensuring data integrity, consistency, and recoverability. Design optimization, incorporating these properties in the early stages of database design, optimizes the system for efficient transaction management and recovery. This proactive approach minimizes the risk of data corruption and loss, and also for a continuous management, where managing a database involves ongoing consideration of schedules, characteristics, and continuous monitoring, optimization, and recovery planning are essential to maintain a high performing and resilient database environment. So, thank